Thank you very much for the introduction. So yes, our presentation, Securing America's Tungsten Future. Usual disclaimers to read through at your leisure. So I just want to give through quickly the investment highlights. Firstly and foremost, USA tungsten. Tungsten is a very hot commodity at the moment, and where better to have it in the USA. They are rapidly depleting their stockpiles and looking to replace with replacing munitions. And we have a high-grade past-producing asset located in the best jurisdiction for mining globally, Nevada. And we're rapidly moving towards our maiden drilling program. The project has been performing very well since we acquired it late December, and some examples of that are achieving a gravity concentrate on metallurgical samples up to 63.6%, high-grade surface sampling in our due diligence field visits, and a geophysical program which has helped establish the potential scale of the system. We've got extensive work programs currently underway, which will feed into good news flow. We've been sampling the tailings dam. This is from mining in the 1950s. We've got stockpiles on site, and we've sampled that, and we look to be getting those results in the near future. And we've got the metallurgy that I've mentioned underway, which is moving from gravity test work into flotation test work. And we've got a conceptual processing study looking to bring this all together into a flow sheet, which we believe we could, in future, deliver a processing plant for the project. This is culminating in maiden drilling, which is scheduled for late in the June quarter. As Chrissy alluded to, tungsten is doing very well at the moment. We're at all-time highs, trading 10 times higher for APT, which is a derivative product from a scheelite concentrate, which is used into the manufacturing industry. That's up tenfold since early 2025. There's also supply shortages, which are compounded by geopolitics and global issues, which I'll touch on in a moment. Just a quick corporate snapshot. Our board members on the right there, me in the centre, Charles Thomas and Dr. Julian Stevens, also as a non-exec. The project acquisition occurred in December, which you can see on the chart there is initiated by a very large spike in volume. And since then, we've seen some good share price appreciation. We were trading about 0.6% at the time. The project performed well continually. We did see a spike at about 2.5 cents. Still softened off a little bit lately, but still trading well above the previous values, and still got lots of opportunity to grow. Market cap around $31 million, and we had 4.6 million of cash in bank, which is fully funding our current workflow. So why tungsten, why now? Look, first and foremost, there's no US domestic supply. They rely heavily on imports, which are then processed in country to produce APT, and it's essential to munitions, aerospace, cutting tools, etc. The legislative mandate, the US government have banned the supply of tungsten from China, Russia, Iran, and North Korea coming into the military supply chains, which takes effect from the end of this year. And that opposites to what China has done, which prior to that act kicking in force is actually limit global supplies from leaving China, and they control 85% of the supply chain. This has resulted in a supply chain deficit, which has had stockpiles diminished, and supplies are being consumed by global conflicts. So that's led to this very large rise in the tungsten price, which we've seen lately. We have a huge opportunity for speed to market. We have a brownfield advantage with a past-producing mine, which I'll go through shortly. It's high grade, stopes up to 3%, drill hits up to 4.8%, and we see an opportunity for rapid start development opportunity for this project. So just to go over our assets, the deal that we struck actually acquires 6 projects in Nevada, and they're on the map on the image there. We've got Alpine, Ragged, Long, Linka, Victory, and Terrell. Linka is what I'll focus on, and the reason I'm focusing on this one is we have a huge technical advantage. Not only was it the most significant producer across the assets, mining at 0.5% grade, we secured a historical data set for the project. For a bit of history on it, the mining was in the 50s, ceased in about 1956, sat idle for about 20 years. An exploration program occurred in the late 70s, which is the data set which we acquired. And then as far as we can tell, there's been no further exploration conducted since then. So it's been nigh on 40 years since a drill bit's been seen at this project. With that historical production, that gives us strong confidence that we can bring the asset forward with drilling as well as other studies which we have underway. Just to set the scene for what the 0.5% mine grade means, so not everyone knows what 0.5% tungsten actually is. This chart shows a series of listed companies, not just on the ASX, but globally, London, Canada, the like, and the grades of their projects. You can see there's operating mines or projects that are advanced stages of assessment and feasibility with grades as low as less than 0.1%. These are very low grades. But our project sits at the 0.5% grade from the historical mining, which you can see sits in line with the top tier of projects on this chart. For a comparison in terms of valuations, there's every company on this list, if to name a few, all have market caps well in excess of $100 million, with some such as EQR, which have the Mount Carbine project, as well as the Barracuda project, with a market cap of $1.4 billion. So we certainly have a lot of room to grow with our market cap currently sitting at 30 million. So Linka, this drone image I took in December when I was out at site, looks across the project. We're looking to the east, and there was 3 mines that serviced the mill when it was in operation in the 50s. These are Conquest in the north, on the left side of the image, through Hillside to Linka Pit and Shaft, the namesake for the project. There's a stockpile there, which we sampled with a metallurgical sample, yielded 0.8%. And as we move south, it goes under a thin volcanic cover, which is younger than the mineralized rocks, re-emerging 800 meters away, of which there's a surface sample at 0.6%. I'll show you in some of the subsequent maps why this is a high priority target, but we believe the mineralization will continue as we go under that cover. We've consolidated all the claims in this area. There's also good infrastructure. There's a good road access, as you can see in the image. That's only about 4 or 5 kilometers to the nearest highway, as well as a 230 kVA power line about 4 kilometers to the west of the project. So we have all the ingredients for bringing this project forward rapidly as we get success through drilling. The next 2 slides, I'll just take you from north to south. So this is the Conquest ore body, which was mined for feeding to the mill in the 1950s. And this is the collection of that data set that we acquired from the exploration in the late 70s. There's some very high grades seen in the drilling here on the right-hand map. Some examples there, 10.7 meters at 0.6%, 22.9 meters at 0.6%, and a very respectable 12.2 meters at 1.3%. If you look at the cross-section on the left, you can see the relative position of those, and all that drilling was located really to the east side of the historical workings. What you're looking at on the map, the orange is the intrusive unit that brings in the tungsten. The brown is a limestone unit which has calcium. You mix tungsten, calcium with a bit of oxygen, you get scheelite, CaWO4. So that contact position is the critical area to be exploring. As we move down the contact to the bottom of the image, you can see it says a priority untested contact area. There's 2 drill holes that were completed there in the 70s which didn't drill deep enough and didn't test that contact. And then there's a whole area with no drilling, but there are surface sample results at 0.3%. If you move 800 meters south, we get to Linka, which is where the bulk of mining took place. Here's a vertical shaft shown in the image, 40 to 50 meters deep. 1 level of workings and a shallow open pit at surface. In this date, all the data we see on this screen is data that's collected post-mining, so it confirms that mineralization still remains in the ground at those points. At surface, a very respectable 8.5 meters at 1%. That is very, very high grades for a tungsten project. Drill hole just underneath that, 9.8 meters at 0.5%. Now, amazingly, 2 things to take away from this image is 1, there's a very large area underneath the old workings that wasn't drilled, and that will form a focus of our upcoming drill program. And secondly is the deeper holes, which don't have very much in them, they were limited by the depth of drilling of the equipment used at the time. They really were only able to drill to a maximum depth of 125 meters until they didn't have enough air to be able to drill within the wetter ground at depth. This is not a problem bringing in modern equipment, so our initial drill program will focus heavily within this area. We have a number of other opportunities to test for at Linka. Not only the high-grade outcropping mineralization, which I've just shown you on the image, but we also have the surface stockpiles that I've touched on. That presents an opportunity for us to process that material to generate samples that we can use to speak to offtake partners, give them examples of the material and the concentrates that we can produce, and then they can assess those and we can seek to commence with early discussions regarding offtake. We also have the tailings dam. So we know that the mine was operating at a head grade of about 0.5%. We do not know their recoveries at the time, but if we take an assumption that their recoveries were about 70%, that should leave about 0.2% in the tails. We've completed a sampling program across that tailings dam a number of weeks ago. We're waiting on the assays. Once we receive those assays, we'll have an idea of what the grade of the tailings is. We'll be able to calculate the volumes. And once we've done that, we will move on the next step, which will be to undertake metallurgical test work to see if we can recover any of those tailings. It's important to note, if we have a tails grade of 0.2, that's higher than some of the grade of those head grades of those operating mines that I talked about on one of my previous charts. It's certainly higher than some of the head grades, some of the mines of companies that have billion-dollar plus market caps. So that in itself is an opportunity of potential feed into a potential future production plant. If we step back and look at the bigger picture, I really like this slide. On the right-hand side, the orange to blues and browns, that's the outcropping mineralization, and that's about 800 meters long. I showed you that in the image with the overlooking the site. To the left-hand side, or the bottom left of that right-hand map, you've got the yellow dashed area. That's that bit that goes undercover, and at the end of there you have the 0.6% sample where the older rocks come back to surface. So that's our high confidence exploration target. Our drilling program, which will be commencing late in the June quarter, is going to have 4 traverses undertaken across that yellow dashed line area with the objective of defining the contact between the limestone and the intrusive, which in turn will then allow us to vector in on mineralization. If we zoom out on the scale basis, however, it shows you the map on the left-hand side. Early on in this project, we undertook geophysical programs. We did close-space magnetics with the objective of defining the intrusion, which is what is bringing the tungsten into the area. And we believe from the interpretation of that, we've defined an intrusion with a perimeter of about 7 kilometers. So the 800 meters that's got mineralization known at surface represents only 11% of that 7-kilometer perimeter. The remaining 89% is untested and really generates the blue sky potential. So again, this early drill program that we're doing will have a portion of the drilling dedicated to putting initial scout holes through the shallow cover that overlays the intrusion to try and identify what the rocks are underneath, whether it be intrusive or limestone. Then a subsequent drill program, we can go and drill between 2 holes which have different rock types in and look to hit the contact. So it gives us really big upside potential. None of this would be any good if we didn't have a processing flow sheet to match any resource that we could define. So in order to do that, we started very early with the metallurgical test work. So we collected 4 samples in the due diligence work. One of those 4 samples, there's an image on the right-hand side. Great looking photo, it's under a black light. Scheelite has this unique property of fluorescing under UV light. So that's the rock samples that we started with. That's crushed, ground, and then put through a gravity processing test work initially. And the bottom image shows the scheelite concentrating there. The white bands is the scheelite on the Wolfley table, and then the darker mineral underneath is the waste, which is primarily garnet. This proved very effective. We yielded a 63.6% premium scheelite concentrate, which is well within marketable grades. And then taking a lower grade portion of concentrate as well, we attained a 46% recovery into a 56.4% WO3 grading concentrate. The next step is to recover further material through flotation. This is a common processing flow sheet that is employed for tungsten. So we've completed the initial rougher flotation. We saw good recoveries in there. We're currently going through the cleaning test work in order to enhance the grade and maintaining a target overall grade greater than 50%. This flow sheet really supports an evaluation of a low capex modular processing solution. So in order to assess this, we have the processing concept study that we initiated with Mineral Technologies. They develop and build both the engineering solution as well as make the equipment, and they have what's called the Flex Series technology. This is all built off-site, shipped to site, bolted together, put the pipework in, and away you go. Their studies commence with developing the flow sheet, which you see on the right-hand side. It's straightforward, crush, grind, gravity separation, flotation, and they're in the process of completing the CapEx estimates, OpEx inputs, as well as delivering a design model and a construction timeline. This is a small processing facility that will process 43 tons per hour. You do the maths on that, it's about 300,000 tons a year, but that gives us a capacity to produce 1,000 tons of scheelite concentrate. So just to wrap this up, first and foremost, we've got 4.7 million cash in the bank. So we're fully funded for the work program presented below. We've been very successful. We've had high-grade samples achieved from our due diligence field sampling. Historical data has expanded the size of the project. Geophysics has expanded it even further still. Metallurgical test work is delivering key results, which has allowed us to move on to a processing evaluation. And that in turn is then moving into permitting. We've got a faster market strategy, which is really envisaging delivering these different steps in the pipeline running parallel in order to be able to get this project moving as rapidly as possible. So before Chrissy makes it over here, very quickly the news flow on the bottom. We've got test work results coming out in the next month or so. We've got geological field activity. We just submitted our permits to commence our drilling. Once we get those permits, which we expect in the next month, we'll be commencing a drilling program late June. We'll be getting assay results through August, and in parallel with all of this, we're conducting baseline studies with the objective of acquiring all the data we need in order to be able to move forward with a mining permit application in the future. Thank you very much.